Okay, so right now we will be going into inferential statistics, which is our last topic for Excel, and we move to the next two. So this time around, what do you know by inferential statistics? You know, there was a time we were treating different types of data analysis, and we're talking about predictive analytics. We talked about a lot of analytics that we have. But right now, we'll be dealing with inferential statistics. We all are familiar with statistics normally. But this time around, this is inferential. We all are familiar with statistics. We all did statistics, if not in our basic school. We did it probably in universities, and some of us in science classes would have, touched statistics in one way or the other. So right now we have, what do we mean by inferential statistics? Like I told you, we have a long way to go today. So inferential statistics helps us make conclusions or predictions about a population based on a sample of data. That is, this statistics deals with you predicting what might happen in the future based on the data you have. Now, what do we mean by that? Now, we have different inferential tests, but what do we mean by this prediction of a thing? For example, let's say you have a data, probably you collected the data for a particular, or let's say we have different samples. We're going to treat that. Let's proceed. Don't worry, we're going to treat that. So now we have inferential tests, different types of inferential tests. We have the t-test for comparing means between two groups. If you want to compare two groups, you want to compare means between them, you make use of t-test. ANOVA, this is analysis of variance for comparing two groups. Why correlation and regression analysis? Correlation is used to test for relationship, regression is used to test for influence, to test for effects, and so on. So we have Z-test and we have F-test. Now let's quickly run through this scenario. Now suppose you want to know if there's a significant difference in sales performance between two branches. Probably you are given a data set with two branches and you were informed. They told you, they called you and they said, we want to know, is there a significant difference between the samples of data that you collected from two branches, branch A and branch B? Now, what are the things you're going to use? This is comparison. We use t-test to determine whether the difference in their average sales is statistically significant. Now, in summary, inferential statistics in Excel, they allow users to go beyond simple averages and charts. And this is not even chart this time around. It enables you making decisions. You making decisions that are gotten from the data. You making predictions to predict something, to predict the future. Okay, probably so far there is a difference between this thing. This and this might happen in the future. To test a lot of things, to know the relationship, to know whether something has effect or something would have effect. So, hypothesis testing. What do you mean by hypothesis testing? From hypothesis, I believe you all are familiar with the word hypothesis. When they say you are making an hypothetical, statement, what does that mean? It means that is a proposed testable explanation. We use it for phenomena. For example, let me say, the boy. Let me just use a very simple scenario. Let's say, for example, you want to know whether the boy is black. Hypothesis is in two ways. We have the null hypothesis. Null hypothesis is always the negative. We can't call it, but let's say the not aspect. That is, what I mean by that is that I can say the boy is not black. I'm just using that. That's not major hypothetical. I'm just using that. The boy is not black. That means it is null hypothesis. Hypothesis might be the boy is black. Now, the major thing is now, what do you now use is until you finalize your testing. That is when you can now conclude if the boy truly is black or the boy is not black. Now, let's use another hypothetical statement, like I'm thinking of one. Okay, let's say we want to use tax in Nigeria, for example. We want to run an hypothetical questions on tax. We can say tax reform has a significant effect on Nigerians' GDP. The second hypothesis might be that because when there is a negative hypothesis, there will surely be a positive because you don't know. Hypothetical is just like you proposing something, you assuming until you test. That's when you can confirm. That is what we mean by hypothesis. And you need to test this hypothesis using your inferential statistical test. So quick one, let's quickly run through it. And also, you need to understand where we use our different tests. You need to know where we use the different tests. You know, I told you t-tests, I told you a lot of tests. You need to understand where we make use of those things, where we make use of them. So now, quick one. You know, we've done descriptive now. You know what descriptive comprises of. This time around, we're in inferential. So quick one. Let's say you are working on you know, we have different types, and you need to understand what we make use of those. So ANOVA, it works for categorical variables. You need to understand that ANOVA works for categorical variables. What do I mean by categorical variables? You know, it works for categorical variable and numerical variable. For example, you are working between, let's say you want to make use of, let's say category. I'm thinking of a categorical variable that we can actually use. That is variables that has categories. It works for categorical variables and numerical variables. And the categorical variable must be more than 2 or more. For example, what do you mean by categorical variable? When we are saying gender, gender is male and female. That's a categorical variable. Male, female is a category under gender. So that is the categorical variable must consist of 2 or more. That's categorical variable. So let's say, for example, you want to test relationship between gender and probably their months they are earning. You understand? I'm just using that as an example. That is categorical variable. So we use ANOVA for that kind of a thing. And the t-test works for numerical value and benchmark. For example, what do you mean by benchmark? Benchmark is target. That is the target. You know, you are working on a particular target. Okay. You want to, let's say, you know, we are trying to compare 2 branches together. You know, I told you it works for numerical value and benchmark. I'm just using that. Let's say, okay, let me quickly run through this. Let's say we have numerical value. Let's say our numerical value is, we have 3, 4, 5. Okay, let me use figure. Let's say 300. Let's say 500. Let's say 600. Let's say 1,000. And the benchmark is, let's say the benchmark is, you know what I mean by benchmark now? That is the target. That is, if they meet that target, you want to confirm. If they meet that target, is it like meeting that target? You know, you want to use your t-test to confirm. You understand? To know if you want to use it to get what's it called? You want to use that benchmark is just like a target. Let me say, for example, we are saying 300, 500, 600, 1,000, and if the target is 500, or let me say 1,000. So 1,000 is the benchmark, which means this is the benchmark, and the only thing that makes the benchmark is 1,000. So now, we start to work for numerical value. You understand? It works for numerical value. Then also we have different types of t-tests. I'm just the one I just explained. This one is sample. So we talked about ANOVA. Then another one we have is chi-square. Chi-square is 2 categorical variables. What do I mean by categorical? You know, I've explained. They are non-numerical variables. They are non-numerical variables. Probably you want to confirm, you know, analysis between. I'm thinking of a non-numerical variable that we can actually use. So, you know, those are part of the things you just need to understand. Now, when we're talking about chi-square, it helps 2 categorical variables. That is, you know, ANOVA helps in categorical variable and numerical. For example, gender and price of a thing. That is an example. Why chi-square only works for categorical. And categorical, what do you mean by categorical? Just let's say gender alone. You understand? Or probably branch A to branch B. That's just an example. So how do we now run this analysis? How do we run this analysis for inferential statistics? Let's say I want to run analysis for this now. I will just highlight, you know, okay, let me run for what's it called? Let me run for ANOVA. Let's say I have male. I want to run for ANOVA, female, for example. Or let's just use t-test to compare. Let's just use t-test to compare straight up. So let's say here also we have 200, we have 100, we have 400, we have 4. Now I want to compare branch A and branch B together. For example, we want to compare both together. So I'm just trying to, let's say price A and price B. So now I want to compare this now. What are you going to do? You highlight. After highlighting what you want to run, you might highlight, you might not highlight. You will still need to. I'm just saying so that you can know this is what I'm working on. This is what I'm working on. So after highlighting, you come to your data. So in your data, you look for data analysis. You can see data analysis, you click on it. Under data analysis, something will pop up. You wait for it to pop up. Good. You can see. Now, these are all the tools. This is, if I just want to test for descriptive, I'll click on descriptive. If I want to test for ANOVA, these are all the different tests. Now, what I want to make use of, I want to run for t-test alone. T-test, pair 2 samples for means. This is what we want to work on. You understand? This is just what we want to work on. And that is what we want to do. 2 samples for means. We have different. So this is t-test I want to work on. Just click on OK. Now it's asking me value range 1. I told you, you highlight the value range 1. Now value range 2, you highlight the value range 2. You can see. Now hypothesis mean difference. If you have that, you click on it. Now you leave this to 0.05. Now output options. Where do you want it to go? New worksheet ply. That is where I want it to go. I want it to create a new worksheet. Just click on OK. You can see this is it. Now, the major thing here, this is my result. You can see my result. I have my mean here, variable 1, variable 2, my variance. So I want to show you something. Now, you can see my variance. Now, the major thing I'm looking for here is my p-value. Now, this is my p-value because that is actually what you look for. So I have my mean, my variance, my Pearson correlation. I don't need that. Hypothesis mean difference 0, df, t-stat. So, and there's a particular thing we should understand about our, what's it called, our inferential statistics. We use 0.05 is always what we use. So if your p-value is, that is what you need to understand. If your p-value, there's something, if your p-value, that is your two-tailed significant, this is it. This is my two-tailed significant, this one here. If your two-tailed significant is less than 0.05, if it is less than 0.05, it means it is significant. It means what? It is significant. So you need to understand that. It means it is what? Significant. So that is what you should understand. And that is from the result. This is p-value of, the p-value here is what? 0.06. The p-value of 0.06, that is how you write inference. That is, let me just put it somewhere. You write inference. What is now my inference? You write it out. That is from the results. From the results, comma, p-value. I told you your p-value is under your two-tailed. From the results, p-value of, from the result, p-value of what? What's our p-value? Two-tailed. Our p-value is what? 0.06. 0.06 indicates that we what? Indicates that we reject alternate, probably our hypothesis states they are what's it called, variable 1 and variable, or let's say price 1 and price 2. I told you hypothesis is your probability, that is, you have it in 2 ways. Your null hypothesis, let me write it here. My null hypothesis, let me write it in the, what's it called? Yeah. Let's say my null hypothesis, which is HO. Let's say my null hypothesis is price A, you know, we are comparing both, is different. Null hypothesis, okay, is not different. Null hypothesis carries not different, is not different to price B. This is just sample, you know, it's not real life data. I'm just using it as an example. H1, which is my alternate. HO means null hypothesis. Why H1 means alternate. H1 means alternate hypothesis. Most of it that you've done, probably you've done your, you know, undergraduate. I'm so sure you'll be familiar with all this. Now, my alternates, you know, price A is not different, or let's say price A and price B are not, okay, it's not different to price B, or price A and price B are not different. Anyhow you want to put it. Now, alternate to be what? Price A and price B are different. So, you know, this is my null hypothesis and this is my alternate hypothesis. So, based on my results now, I can say inference from the results, p-value of 0.06. And don't forget, I told you 0.05 is always our what? 0.05 is what we use to measure significant and non-significant. Which means if it is less than 0.05, what happens? If it is less than 0.05, you accept alternates. But if it is greater than 0.05, you reject alternate. You know, this is your alternate and this is your null. Now, this one we have 0.05 and our p-value is 0.06. From the result, the p-value of 0.06 indicate that we what? We reject our what? Alternate. We reject our alternate hypothesis. We reject our alternate hypothesis and accept our null hypothesis. So this is my inference, which is my conclusion. So you can see with this data, we're able to predict. So which means price A does not, what is our what? You know, we said from result, p-value of that we reject alternates. We reject alternates. That it is alternate. So, and we accept none. So which means price A is not different to price B. So the statement will not be price A does not have significant or has no significant difference, or price A and price B has no significant difference. Or you can still make use of your word that says price A is not, you understand, is not significantly different to price B. You understand from this inference. So those are inferential statistics. So we have different ways to run inferential statistics. We have different ways to do it. And I think I will stop here regarding this. So you've understood, I think you now understand how we run inferential statistics. So we have difference, you know, when you click on your data, you can see ANOVA, you can see descriptive, and so on and so forth. So if I want to run descriptive now, I will just click on that analysis. Descriptive will bring out the mean, everything. We have correlation to check if there are correlation is used to test relationships. So if I highlight all these now, I don't need to highlight like I told you. I just want to know where I'm clicking on. So if I click on correlation now, I want to test if correlation is used for what? To test relationship. If I click on OK, input range, this is my input range. Now it's telling me what am I grouping by? Am I grouping by columns or rows? I'm grouping by columns. You click on columns, new worksheet, then you press OK. So with this now you can see 0. This is column 1 and column 2. You understand? So it has given us the, what's it called? The correlation results. So that is all about what? Your inferential statistics.